I would. Worksheet. Okay, number 1. Now, some of you are probably not going to have enough room on this paper because you might write a little large. You might want to get out more paper. Just want to throw that out there. Not wanting to put any names out there, but yeah. Okay. Okay, so now, numbers with numbers, letters with letters. Before you rearrange, though, I want you to put on your missing exponents. Step 2. Numbers with numbers and letters with letters. Step 3. Treat them all as separate problems. Keep this in mind. Know when to add, subtract, and multiply exponents. What's the matter? Those have lotion in them. Those are my nice ones. I don't care. Oh, is it a tissue or you need or a napkin? Oh, there's some over there. And then lastly, get rid of all negative exponents. He's what? It smells yummy, doesn't it? You just say that because you're mad at me. Okay, now, this is something that should help you to be able to do these problems. So you're going to put your missing exponents on, you put your numbers with your numbers and letters with letters, treat them all as separate problems and knowing when to add, subtract, and multiply exponents. And then you're going to get rid of all negative exponents at the very end. Do we get that, yes or no? This is the same thing we've been learning, okay? I'll print it for you later. Okay, number 1. Am I missing any exponents on the 16? So put on a 1 on the 16. So now what do I do? Numbers with numbers, letters with letters. Yes? Okay, now what is the difference between a negative exponent versus the negative number? What does the negative exponent mean? The negative number means that you owe somebody money. You're in debt. You borrowed $16 from somebody. Does that make sense? 4 to the negative 3 means that we're not allowed to have the negative exponent. And at this point, we're going to treat this each as separate individual problems, just like step 3 says to do. Treat as separate problems. So at this point, I'm going to get rid of that negative exponent. Not the negative number, but the negative exponent. Do we get that? Because the exponent on the 16 is a 1. And it's a positive 1, right? So it stays right where it's at. So the 16 stays at the top, and it's still negative. And the bottom goes to 4, becomes 4 cubed. Yes or no? Hello? Do we get that? So now the top is still negative 16, and the bottom becomes, what is 4 times 4? Could I stop right there? Why would I want to stop right there? So they cancel each other out. So 4 times 4 is 16, but I still have to multiply it by 4 again. Why? Because that's what 4 cubed is, right? 4 times 4 is 16, but I still need to do it one more time, so I still have to put that 4 down there. So now what do I have going on here? The 16s cancel out, and now I'm left with a -1 over 4. Yes or no? I'm not done with the problem. Do we all understand that? Because the 16s cancel out. 16 divided by 16 is 1. And that negative still has to stay. Do we understand that the number part of the problem is done now? So now I go back up, and I'm going to do my A's. So what do I do to my A's? How are they attached? By what operation are my A's attached? By multiplication. So what do? You add the exponent. So this is -2 plus -5, which becomes a to the -7. Well, where does that a to the -7 need to go? Extend this fraction. It's negative in the top, so to make it positive, where does it go? It goes to the bottom. So now I have to extend this, and I'm going to have a to the 7th down there. Do we see that? Yes or no? Go back up. What do I do with this? B to the, what do I do with the exponents? You add them, so this is going to be -1 plus -4, and that's going to be b to the -5. Again, put that over 1, and now what do? It's negative, right? So to make it positive, I go to the bottom. Now this is done, and I can actually move that -1 and put it in the middle. Do you see how I took it step by step by step? Yes or no, people? Do you see that? Easier? Let's do number 6. Brian, do you have one? I didn't give you one? Did you eat lunch? Step 1, what do I do? I just inherit kids at different periods. I love it. What do I do? No. I put on the missing exponents. So the 7 is having a missing exponent, 8 has a missing exponent, and the v has a missing exponent. Now I take and multiply that exponent on the outside to every base with every exponent on the inside. So this becomes 7 to the -2, u to the what? +8, v to the -24, all over 8 to the -2. Do we all see that, yes or no? Are we good? Okay, so now, go ahead and treat these as individual problems. Do you see that? So if I deal with my number problem first, 7 to the -2, 8 to the -2. Well, my 7 to the -2 is currently in the numerator. So to make that positive exponent, what do? I put 7 squared to the bottom. 8 to the -2 is negative in the bottom, so where does that need to go? To the top, so this becomes 8 squared. What is 8 squared? And what is 7 squared? Do you see that the number part of the problem is done? Yes or no? Okay, go back up. Now look at my u's. What do? 8 minus 36. Why am I subtracting my exponents? Because they're attached by division. And since they're attached by division, it tells me to subtract the exponents. So what is 8 minus 36? U to the -28. Now, I'll deal with that in a minute. Are we all okay with dealing with that in a minute? Or do you want to finish it off? Finish it? Okay. So I extend this. Now where does that need to go? So now I have 64 over 49 u to the positive 28. Do we see that? The view's done. I go back up. Now what do? The v to the what? So negative 24 minus negative 2. So minus a negative 2 is what? Plus plus, so what's that going to become? Negative 22, extend the fraction, and where does it go? It goes down to the bottom to become v to the 22nd down there. And we're done. Does that make sense? Is it as hard as what you thought it was? If I wouldn't have gone over it, would you have had a panic attack and not be able to do it? I'm sorry? You guys are evil. You guys are just upset because I care about your education rather than I care. My game in life is to make students' lives miserable in any possible way that I can, right? That's my end game. Yes, I'm that mean. Number 10, what do? I like how I'm doing homework problems off your worksheet and you guys have yet to write one of them down. Why 10,000? Tens, hundreds, thousands, 10,000. So this is going to be 81 over 10,000, the fourth root of it. Divorce them. Tear them apart. So this is going to be the fourth root of 81 over the fourth root of 10,000. Yes? Now what number multiplied by itself 4 times is 81? It is 3. So this comes out as a 3. And what number multiplied by itself 4 times is 10,000? 10. So now I have 3 over 10 being my final answer. Really? It's not that difficult. I wonder if I heard that already today. Huh, that's it? The easy ones are hard, and the hard ones are hard, but they don't seem that hard anymore. Because 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So 10 to the fourth is 10,000. Does that make sense? Okay. $16. Number 16. What do? Marry them. Because how do I know I can marry these? If you look right here and right here, there's nothing there, which means it's understood to be what? The square root. Do we all understand that? Peace, what up? Okay? So I'm going to go ahead and take 7 times 2, which is 14. And then I'm going to have 42 times 56. And then what's x squared times x to the 5th? X to the 7th. Y cubed times y cubed? Y to the 6th. Okay? Do we all understand why we added those exponents? Yes? Okay. At this point, many of you could go ahead and take 42 times 56 in the calculator. But you're going to get this big answer, and you're going to have no clue what all the perfect squares of it are. And you're going to take forever to try to do it unless it's a perfect square itself. So how do we go about dealing with this without having to do a whole bunch of thinking on our part? Give me 2 numbers and multiply together, give you 42. 6 times 7. Give me 2 numbers multiplied together, give you 56. 7 and 8. Now, is 7 divisible by my index of 2? Is 7 on my x divisible by my index of 2? So what is the first number smaller than 7 divisible by 2? 6 and what? X to the 6 times x. Do we all see that? Is 6 divisible by my index? So what's that going to be? just y to the 6. Okay. How many 7s do I have going on there? 2. So do we understand that that's actually going to be 49? Yes? If you realize that and you don't want to write it like 49 because I could just now see the look on your face, if you want to write it as 7 squared so that you know it comes out like that, that's fine. Okay? Now, because that's going to give me the 42 times 56, and our brain doesn't want to think like that. Now, what is 6 times 8? Does 48 have any perfect square factors? What? There's more in 12 than just, there's a perfect square in 12, so we got to go higher than 12. What? Higher than that. Well, think about it. 4 and 12 is 4 times 3, so 4 times 4 is 16 times 3. Do we all understand that? So this is actually going to be 16 times 3, x to the 6, x, y to the 6. Okay? So what we're doing is just trying to find the perfect square factors of that big, humongous number. So what is the square root of 7 squared? What is the square root of 16? Square root of 3? Square root of x to the 6? Square root of x? Stays. Square root of y to the 6? So now, you're going to take 7 times 4 times 14. And when you do that, no, 7 times 4 times 14 gives you 392. I did. X cubed, y cubed times the square root of 3x. I did it differently on my paper. You didn't do the last step of it, remember? There was. We took 7 times 4 to get 98, and then we took the square root of 16 to get 98 times 4 to get 392. Uh-huh. Okay. 6 times 8 is 48. Now I'm looking for factors of 48 that are perfect squares, and that's where the 16 times 3 came from. I mean, you're more than welcome to go ahead and do 42 times 56, and then understand that that's going to be, 392 times 3. Actually, it's going to be more than that, sorry. Okay? Do we all understand that? Okay. That is number 16. 22. You should be working on all the other ones. Okay. Good to know. Okay, what would you guys do? Miriam. 3 over 28 times 175 over 3. What happens to the 3's? They cancel out. And can I rewrite $1.75 any other way? How many quarters would you have in your hand if you have $1.75? 25 times 7, right? Can I rewrite 28? What happens to my 7's? So now I actually have 25 over 4 in here. Now what would you do? Divorce them? Or just take the square root of them? Okay. I'm going to divorce them so everybody understands where they came from. That's the square root of 25 is 5 and the square root of 4 is 2. Do we all understand that, yes or no? Okay. Now I've done every form that you could possibly find on there. Now I do want to talk about one other one. The square root of 25 is 5. Does that make sense? Number 11. Number 11 On number 11 there. The directions say what? Simplify and find all the real roots, right? Real. Can you have eyes? Imaginary numbers are your eyes, and you're not allowed to have imaginary numbers. Does that make sense? So what root am I taking of this? What index do I have? My index is 2. So what I'm doing is I'm taking the square root of -4 over the square root of 25. What's the square root of -4? What number multiplied by itself is -4? There isn't one. Remember, the -1 is your I squared. So this gives you imaginary numbers, which means do I have any real roots here? No real roots. It doesn't matter where it goes. It can go to the top or it can go to the bottom. That negative can go to the top or it can go to the bottom. That's it. You don't do anything. Anytime you have a negative underneath the index, that is an even index. Anytime there is a negative underneath of an even index, you cannot do it because that puts you in the imaginary number system. If the directions say you can be in the imaginary number system, then you can do it. But if the directions do not say, then you may not. They'll be okay. Are we good? Do we understand? Are there any other questions? 13. Oh, no, clearly some of us think that we don't need to. Be the teacher. No, you're salty because you're angry that I'm not letting you get your way. That's okay. Okay, what do I do? Okay. 5th root of 1 over the 5th root of 243. No, you're thinking of rationalizing. We're not going to rationalize that. Okay? Now, what number multiplied by itself 5 times is 1? What number multiplied by itself 5 times is 243? 3 times 3 is 9 times 3 is 27 times 3 is 81. And what's 81 times 3? That's it. There's not. Okay, are we good? I want you guys to spend the rest of the time working on this. I'm done for the day.